So this is not for you. Use this one. Yeah. Not this one. This one. Yeah. Okay, so we'll continue with where we stopped. We've not finished indices, so today's class will be the indices 2. And then we will move to logarithm if time permits us. So these two topics are very important for why there's no exam that you dodge those two topics. Okay, so indices and logarithm. Now, for the indices, we'll complete the indices within the next 30 minutes, and then we'll focus on logarithm. So for the indices, we're going to just do exponential equations. So we'll be focusing on exponential equations. So that's our focus exponential equations. Great. Oh, this is not the place I'm supposed to start. Not here. Okay. Let's start from somewhere. So indices 2. So and logarithm. So for the indices, we are doing the exponential equation. So know that there are cases where the resulting indices that we have are turned into equations. So and some of these equations that we have may be simple linear or some. So we may have equation of this one. So it may be simple linear or simultaneous equation. So under this topic, you should be expected to use your knowledge of simple linear equation or simultaneous equations. And also, you are expected, you may see questions that will test your understanding of quadratic equations. So these are what you should be expecting. So the equations you may form may be simple linear equation or simultaneous equation, and it may be quadratic equation. So depending on the problem. So prepare your mind for that. So we're going to begin from the very simple linear equations, and we're just going to solve some problems. So we'll just go directly to problem solving, but we'll begin from the simple cases. Our approaches will progress from the very simple case to the more difficult ones. So when you understand the simple cases, then it's easier to solve problems that are tough. So the first one we're going to look at is if the cube root of 4 to the power of 2y is equals to 8. Find y. So these are questions that fall under exponential equation. And this, you'll see this in JAMB, WAEC very, very well. So let's see, how do we solve this problem? Let me hear from someone. What's the best approach we can use to solve this problem? Anybody? Come just unmute yourself and talk. Who will do that for us? How do we solve that question? What's the first approach to use?
So I think the rules, like you have to follow the rules.
Okay, so which of the rules are we applying here?
The it doesn't have a name.
Okay,
It doesn't have,
okay,
but with I feel like it's going to be um 4 raised to power 2y, like a big 4 raised to power 2y 1/3. I'm not sure.
excellent. I think that's a good way to start. Okay,
Oh,
that's a good way to start. So let me rewrite the equation. So I have cube root of 4 power of 2y equals to 8. So based on what Nancy said, so this cube root becomes 1/3. That's what you mean, right?
yes, sir.
Okay. So these two, I can express it as, let me just write 8 first. So we can express 4 and 8 to have the same base. So 4, the way we'll do it, 4 is 2 into 2, and 1, that's 2 squared, right? So I'm writing 2 squared as 4, but we have a power here, 2y, and we have another power, 1/3. Then 8, if I put 8 here, so we have 2 to the power of 3. So 8 is 2 to the power of 3. So ask question if you get confused at any point. Ask a question. All right. So I can continue, right? Now, so let's do this. Let's apply, these are powers of powers of powers. So we multiply these powers. So I have 2 times 2y times 1/3 is equals to 2 to the power of 3. So what do we have there? 2 to the power of 2 times 2 is 4. So I have 4y/3 equals to 2 to the power of 3. Now we can see the bases are the same, so we can cancel the bases. So we're left with 4y is equals to 3. 4/3 is equals to 3. Okay, ask a question, Nancy.
So why didn't you add 2 plus 2y plus 1/3? Why did you times it?
Remember our law, powers of powers. If you are powers, you are multiplying. It is not like saying, this like saying, it's not like this, like saying 2 to the power of 2 times 2 to the power of 2y. They are not the same.
Okay, so
So for this case, we are going to do 2 plus 2y like this. But this is power of power. Okay, let me give, if you go to your law, the law we did, you will see that power of power that if you have a m to the power of n, so it should be a m times n, because both of them are powers. So and that's what we applied here.
Oh, I understand now, sir.
So now, thank you. Okay, so here we can cross multiply. 4y times y is 4y. 3 times 3 is 9. So we can divide both sides by 4 to get y. So y is 9 over 4, which is 2 whole number, 1 over 4. So that's the value of y, 2 number, 1 over 4. Any question?
No, sir, I don't have a question.
Okay, so let's check another one. Number 2. And this one is a jump question. So it's almost the same thing what we did. So given that 2 to the square root, the cube root of 4 to the power of 2x is equals to 16. Find the value of x. Find the value of x. So solution. So we have that, so the cube root of 4 to the power of 2x is equals to 16. So we'll use the same approach as Nancy suggested before. So this cube root will turn it to a power, so it becomes 1 over 3. So 4 to the power of 2x, so 1 over 3. Then we express 16 to base 2, and to have a base of 2. So that will be 2 to the power of 4. So we can also do this 4 is the same thing as 2 squared. So that's a 4 there.
Excuse me, sir.
Yes, can I ask a question?
Please, can you scroll up a bit?
Yeah.
Yes, thank you.
So if you are not asking question, make sure to mute yourself so that the, the class will not be noisy. Okay, can I scroll up now?
Yes, sir.
So this, the red pen there is for 4. That's 4 is now 2 squared. But remember, we already have the 2 to the power of x there already. And we'll have 1 over 3 there. So now we're going to multiply all the powers together. Since all of them are powers, we multiply them to have 2 to the power of 2 times 2x times 1 over 3 equals to 2 to the power of 4. So 2 times 2x is 4x. So I have 2 to the power of 4x over 3 is equals to 2 to the power of 4. So we can eliminate the base from both sides. So 2 to 2 cancels. So I'm left with 4. So I'm left to be 4x over 3 is equals to 4. So we can cross multiply. Yeah, 4x times 1 is 4x, equals to 3 times 4 is 12. So we can divide both sides by 4, so that x becomes 12 over 4 to give us 3. So the value of x in that equation is 3. So ask a question before we proceed. So these are just the, so as we progress is to get tougher and tougher. We are still doing, all this one are the simple. Remember we said the question may lead to either a simple equation or a simultaneous equation. So all these ones, the first two we did are just simple equations. We are not seeing any complex equation. They are just simple equations. So let's question 3. So question 3 says, if the cube root of 3 to the power of x is equals to the square root of 3 to the power of equals to the cube root of 3 of 9. Please do not scribble, no annotate. Okay. So this is what we have. So what is the value of the of x? So let's, so what we have is the square root of 3 to the power of x and the cube root of 9. So we'll be using the same approach that we'll be using. The what somebody suggested for the first question. Remember, this square root means there's a 2 here. So square root becomes, when we're changing it to power, it becomes 1/2. So I have 3 to the power of x, then the square root becomes 1/2. And here is cube root, can write 9, the cube root becomes 1/3. I hope the first step is not confusing. So now multiply this power, we have 3, x times 1/2 is x/2. Then we can express this 3 to have a base of 3, 9 to have a base of 3. So 9 is 3 squared, but we have 1/2 there. It is 4, so 1/3 there. So we have that. So the next thing, we have 3 to the power of x/2 is equals to, so let's multiply 2 times 1/3, we have 2/3. So we can cancel the bases. So we'll be left with x/2 is equals to 2/3. So let's cross multiply. X times 3 is 3x, and 2 times 2 is 4. So let's that x will be 4 divided by 4/3, because one whole number is 1/3. So that is the solution to that, x equals to 1/3. So we can see how easy it is. So let's take it, let's take it to another level. Yes, ask a question. Okay, like your network is not stable, so your voice is breaking. So I can't really get. Maybe you can step out of where you are. Your network is not strong enough. Okay, so this is another question. If 8 to the power of 1 minus 2x equals to 1 over 4 to the power of x, let's find the value of x. So as we solved in our previous class, we express each of these numbers as to the same base. So let's say, so 8 power 1 minus 2x equals to 1 over 4 to the power of x. And for me, I would like to take this 4 up. So first thing, that's what I want to do. So this 4, when it goes over 4 to the power of minus x. So I just want everything to be like that. But they are different ways. Some persons may decide to cross multiply. But I think this will not cause confusion. So now let's express each of these. 8 is 2 to the power of 3. So the red is the power, so I have 1 minus 2 over 3. 1 minus 2x. And then we have 4 is 2 squared. So then we have minus x. So let's expand. Let's multiply the powers together. So I have 2, 3 times 1 minus 2x equals to, so 2 times minus x is minus 2x. That's what we have there. We can eliminate, we can cancel the bases that are the same. 2 cancels 2. So we are left with 3 power 1 minus 2x is equals to minus 2x. So let's expand the bracket. 3 times 1 is 3. 3 times minus 2x is minus 6x. Now I have, so let me bring the minus 2x to this side. So I have minus 6x plus 2x is equals to 3. Okay, when 3 goes there, it becomes negative, right? Yep. So that I'm left with minus 6x plus 2x is minus 4x plus minus 3. So I divide both sides by minus 4. So x becomes minus 3 over minus 4. So minus minus is plus, so I'm just left with x is 3 over 4. So that is the solution to that. So I'll give opportunity for question. And if you know your background is noisy and you can send question on the chat. I'll always read the chat. That's if your background is noisy.
Sir, please, do you mind scrolling up to number 4? I want to see something. Okay, so I can scroll down.
All right.
Sir, please excuse me. Sir, that number 4, can you
Yes.
re-explain it? I have problems with my network, so I had to rejoin back. That number 4, re-explain it.
Okay. Think. Do I need to explain it?
Yes, sir.
Okay, so let's go through it over again. I'm just conscious of time. I don't want us to spend much time the way we did for physics. Okay, so 8 to the power 1 minus 2x. We were in the last class, math class, right? So we normally express these numbers maybe as product of their prime numbers or prime factors or as index notation. So 8 is the same thing as 2 to the power of 3. So that's what we have here. This 8 has been expressed as 2 to the power of 3. There's a power already 1 minus 2x. And 4 here is, let me use a lighter so that you can see it. And 4 here is 2 to the power of 2. You can see where my cursor is. Then we have to the power of minus 1. So these are powers, so we multiply the powers together. So we have 2 to the power of 3 in bracket 1 minus 2x. And then 2 times minus x is minus 2. Since they have the same base on both sides, we can cancel them and we'll be left with the powers to equate. So we have 3 open bracket 1 minus 2x, which is what we have here, equals to minus 2x. So the rest is a linear equation that you can solve. Does that really make sense
Okay,
for
thank
you?
you, sir.
Okay.
Thank you, sir. I understand.
So let's get to question number 5. We're stepping higher. So this one will be tougher. So I want everybody's attention. We solve for x in the equation giving us 10 to the power of x times 5 to the power of 2x minus 2 times 4 to the power of x minus 1 is equal to 1. So looking at this question first time is scary, right? Very scary. But if you start working on them step by step, you begin to break the complexity. Now, if you notice what we have, all of them are having different bases. Now, one idea of solving exponential equations is to bring them to the same base. Now, but we have that all the bases that we have here are different. So what can we do to bring all to the same base? If we can't bring them to the same base, what can we do? Remember this one now, we can't bring them to the same base. So what can we do in this case?
I think you should add the powers together.
We can't add the powers if the bases are not the same.
Sir, I think we should multiply the bases before we continue any further solution.
What do you mean by multiplying the bases?
Multiply the bases on the left-hand side before we continue with
Okay,
any other
so
solution.
how do we do that?
But
Are we doing like
that should,
10 times 5 times 4?
yes, that's what I mean. Yes, sir.
So
Is
it's
it going
not
to be
following
possible?
it's not, that you are disobeying the laws of indices.
What? What are we going to do?
And any
Sir,
disobedience is imprisonment.
sir,
Yes?
sir, I think that 10 is changed to 5 raised to power 2.
5 raised to the power of 2 is 25, not 10.
Oh, yes, yes, wait.
So
Oh,
what's the
yes.
best approach?
Change 4 to 2.
Pardon? Remember,
Changing 4 to 2 raised to power 2.
okay. Remember what we did in that class, when we have different bases, we can express each base as a product of its prime. 10 is 2 times 5, right? They will remember this that we did in the first class when we have different bases. So we'll start from that. Now, when solving some math problem, you may not even know what to do. Ideas start coming as you solve a step. Ideas start, so things begin to open up as you solve step by step. So this is the first thing I'm doing is to change this 10 to 2 times 5, and then this 4 that's 2 squared. Now leave this as it is for now. Now, so we've reduced the number of bases from 3 to just 2 numbers, 2 and 5. So let's see, so we can split this one, 2 to the power of x times 5 to the power of x times 5 to the power of 2x minus 2 then times 2. Remember, this 2 multiplies the x minus 1. So I have 1. So I'm leaving here as it is. So I can bring those that have the same base together. So this one and this one, they have the same base. So I'll bring them together. So I have 2 to the power of x times 2 to the power of 2x minus 4. Then I'll bring the black ones together. That's the base, the ones with base 5, the base of 5. 5 to the power of x times 5 to the power of 2x minus 2 plus 1. So with this one, they are the same base. Now can apply, pick the base and add the powers. X plus 2x plus minus 1. For the 5 to the same thing, pick one and add the bases. 2x minus 2. And here is 1. So let's simplify the, so I have x plus 2 times x is 2x. I'm expanding. 2 times 1 is minus 2. The same thing here, x plus 2x minus 2 plus to 1. So x plus 2x is 3x. We have 3x minus 2 times 5. X plus 2x here is 3x minus 2 is equals to 1. What do you notice?
They both have the same power.
Excellent. That's a good observation. They have the same powers, the same powers. So since they have the same power, we can just multiply the base and just pick one of the power. I believe we follow to this point. So 2,
Yes, sir.
wait, 2 times 10, 2 times 5 is 10, so I have 10 to the power of is equals to 1. Now, remember, we need to make both sides the same base. According to the law of indices, any non-zero number to raise to the power of 0 gives 1. So this one, we can write this one as 10 to the power of 0. So I'm changing this 1 now. Since the left hand side is 10, 1 becomes 10 to the power of 0. Then we can, now we have the same base. We can cancel. So we left to ask a question, Nancy.
So I don't get that side.
This one that changed to 10 to the power of 0.
Yes.
And the reason is we want to make the base the same on both sides. Since we have on our left hand the base is 10, but here we have 1. But we can anything to the any non-zero number raised to the power of 0 is 1. So instead of just writing 1, this 10 to the power of 0 is still the same thing as 1. This 10 to the power is still the same thing as 1. So if the left hand side was 5 to the power of, if we had like, if here this 10, if we have something like 5 to the power of 2x is equals to 1. Since this base is 5, we can just write 5 to the power of 2x equals to 5 to the power of 0. Is that clear?
Okay, sir. Yes.
Great. So we have a simple equation now. So we have 3x, take 2 to the other side, we have plus 2. So x becomes 2 over 3. So that's the value of x. And we've solved that equation. So one thing with this type of problem, if you don't start, you don't know what to do next. If you don't start, you won't know what to do. So you get idea on what to do next from where you are at the moment. So all these things is, I'm just picking the questions. I've not, it's in class, I'm thinking of the steps, I'm seeing what I need to do next from where I am now. So if you don't start, if you see the question that is difficult and you don't start, you will not be able to do anything. But as you start breaking it down step by step, the next thing to do comes up because from what you have at that particular moment. Okay, so do I have to make it a whole number? What do you mean? Is it the 2/3 or what? No, anything you have 2/3 is a fraction, so that's the answer. That's the answer, 2/3. So that's the value of x. Welcome. So let's check some other ones. So this next one, this question 6, right? What's the time? I want to be conscious of time. To 3, so if you have like 20 more minutes. So may not be able to start the logarithm. So maybe in the next class in case. So let's check. This one may be complex more than this previous one. So solve for y in the equation 10 to the power of y times 5 to the power of 2y minus 2 times 4 to the power of y minus 1 is equal to 1. Wait, it's still the same thing that we did, right? That's the same
Yes,
thing,
sir.
the same question. Not you.
It's not like exactly the same question, but like they are the same figures.
That means the same. So yes, it's this one. Solve for x and y. Solve for x and y in the equation. In the equation 2 to the power of x plus 3 to the power of y is equals to 9. And also 2 to the power of x plus 2 minus 3 to the power of y plus 1 is equals to 8. So we have, so this one is one that would, that leads us to a simultaneous equation. So we have two sets of equations here. So let's say this one is our equation 1, this one is our equation 2. So this one is, this question especially for those rewriting further maths, some of this type there. So the first one, 2 to the power of x. So what do we do in this case? Well, who has an idea on what we do here? Okay. Since this, we don't have much problem with equation 1. Where we have much problem is equation 2 because we are having 2 terms as a power. So what we're going to do, I'm going to do that equation 2. So from equation 2, so we have that 2x plus 2 minus 3y plus 1 equals to 8. Now, remember, in our laws of indices, when do we add the powers? When do we add powers? Because this is addition. When do we add the powers?
When the bases are the same.
And you add when the bases are the same and you are multiplying both the index, right?
Yes, sir.
So that's me. I can write this 2 to the power of x plus 2 as 2 to the power of x times 2 to the power of 2. Any confusion there? So this is the same thing as this. Any confusion there?
No, sir, I don't have a confusion.
So that means this one too, I can write it as 3 to the power of y times 3 to the power of 1 equals to 8. And let me leave the 8 as it is. So now 2 to the power of 2 is 4. So I can write 4 times. So 4 is multiplying 2x. I'm putting it in bracket because it's multiplying. So 3 to the power of 1 is 3. So 3 is multiplying 3y. It's equals to 8. Yes, please. Ask a question.
Sir, I don't get.
This 4,
Like,
here, let me, this place, this 2 to the power of 2 is what we have here. 4.
oh,
Then this 3 to the power of 1 is what we have here as 3. Is that clear now?
yes, sir.
So let me say that's what we have as our equation 2. So let me bring equation 1 and equation 2. We have equation 1 is 2 to the power of x plus 3 to the power of y equals to 9. That's equation 1. Now we've transformed equation 2 to this. This is minus, right? 3 to the power of 3 y equals to 8. Now, what do we notice in both equations? They both have 2 to the power of x and 3 to the power of y, right?
Yes, sir.
So we can say let 2 to the power of x be any letter of your choice that is not in this equation. Any letter of your choice. So let me say it's p. And let's say 3 to the power of y. Let's call it q. You can choose any letter of your choice. So it means anywhere I see 2 to the power of x in this equation, I'm changing it to p. So that means equation 1 becomes 2 to the power of x is p. So I'll just write, so let me use a lighter so that I know what I'm doing. 2 to the power of x here becomes p. This is where I'm writing the p. Becomes p plus 3 to the power of y. Let me use this for y. So 3 to the power of y becomes, I'm using a lighter so that I know which ones I'm doing, becomes what? Q is equals to 9. So let me call that our new equation 1. Then equation 2 becomes, so let's go to equation 2. Remember here we have 2 to the power of x here, but there's a 4 before it, right? So I'm going to write that 4 this way. Note my lighter. The 4 is what is outside the highlighter, that's 4. Right? The highlighter 2 to the power of x is p, so I have 4p minus, so I have 3, but we have 3 to the power of y, which we have said that it is now q. So here I'm putting q here. So equals to 8. This is our new equation 2. So you see we form simultaneous equations that we can easily solve. So you determine which method you want to use. Is it elimination method or substitution method? So let's use the elimination method. Let's eliminate q. So how do we eliminate q? We have to make the coefficients of q in both equations be the same. So I'm going to multiply equation 1 by 3. So I'm equation 1, I'm multiplying by 3. So that I will have 3q. So I have 3p plus 3q. 3 times 9 is 27. Then equation 2, I'm just going to multiply by 1. So it would stay as it is. 4p minus 3q is equals to 8. So I have same, since the sign of the coefficient of q are opposites, this is another rule you can tell. If the signs of the coefficient are opposite signs, you just add. So that's when I mean opposite, I have one of the coefficient carrying plus and the other one carrying minus, you add. Then if they are the same sign, you subtract. That if one of the coefficients carrying minus and the one is carrying minus, to subtract, or one carrying plus and the other one carrying plus, to subtract. But in this case, what we have is plus 3 and minus 3, so they are opposite sign. So I'm just going to add. So add equation 1 and 2. So I have, well, that means that 3p plus 3q, I'm adding the left hand side, plus 4p minus 3q is equals to 27 plus 8. So 3p plus 3q plus 4p minus 3q equals to 35. So let's bring the p's together. This is p. This is p. And this is p. So let's bring them together. So I have 3p plus 4p. Then we'll bring the q together, plus 3q minus 3q equals to 35. So these are opposite sign, plus 3 minus 3 disappears. So I'm left to 3p plus 4p, which is 7p, to give us 35. So p becomes 35 divided by 7, which will give us 8. So the value of our p is 8. So we can substitute that value of p, that's p equals to 8, into any of the equations. So let's pick equation 1.
Sir,
Yes?
the value of p is 5, not 8.
Oh, thank you for that. Thank you. So the value of p is
You're
5.
welcome.
Then yeah, it's 5. Thank you. 5. So we substitute the value of p equals 5 into the equation, any of the equations. So let's pick equation, anyone, equation 1. So equation 1 is 3p plus, I prefer this one. Yeah, equation 1 is 3 p plus q equals to 9. So I'm going to write p plus q is equals to 9. So now p is 5, so I have 5 plus q is equals to 9. So q becomes 9 minus 5. So q equals to 4. So we have that p is 4, p is 5, and q is 4. But we've not finished solving the equation. We have to get the value of x. So we have to go back to what we have here. What we stated here, that let p, I'm going to copy this. We say let p equals to 2 to the power of x. So I'm copying that, what we stated earlier. I'm bringing it back here so that I can use. So this is what we say that p is equals to 2 to the power and 2 to the power of x. So now we know that we now have 2x equals to p. Now we know that p is equals to 5. So we have 2 to the power of x equals to 5. So how can we solve this equation? Yeah. Then yeah, q is 4. We have 3 to the power of y is 4. So how do we get the value of p and y there? Okay, let me see. I'm seeing these equations is looking somehow. So let's check the way, did we make any mistake? Why making substitutions? Let's see. Okay. Okay, it's correct. So you need to make sure that your signs are correct. Okay, so what we did is correct. So we just continue. So there's no mistake there. But this is looking somehow. So if you don't have some techniques, you may not be able to continue from here. So to be able, yes, ask a question.
Sir, please, when you're done explaining, do you mind scrolling? Like when you're done.
Okay. So we have 2 to the power of x equals to 5. So how do we get the value of x here? So I think what we need to do here is to change the base. We've not done logarithm. So there's a rule in logarithm called the change of base in logarithm. And that is what we can apply here to be able to solve that equation. So let's change I'm trying to think the easiest way everybody will be able to understand. Okay. What's the easiest way I can explain this?
Sir,
Yes.
if assuming it was logarithm now, the power x we stand alone, while the 2 we move to over the equals to sign and
Yeah.
and power the 5. That will be x equals to 5 raised to power 2.
Yes,
Can it
if
be solved that way?
you can change the base and say, okay, let's use 2 to the power of x equals to 5. So let's take the logarithm of both sides. Log 10 of both sides. So you can say
Yes,
log
log
10
x.
of 2x. I'm just being careful using this because we've not really done indices and logarithm. So this is to the power of 5. Because what you do here, you have to do it to the other side. So from there, from logarithm, this becomes this power multiply the log. So this is x, you can make x the subject formula. So x become log 10 to the log 5 to base 10 over log 10 to base 2. So you can use calculator to do this. Okay, use your calculator to get the value of log 5 for us. Log 5 to base 10. Let me use my calculator. Who is doing that for us? Log 5 to base 10.
Stop. Log 5 base 10 is 0.6989.
0.6989. So log 2 to
Then
base 10.
log 2 to base 10 is 0.3010.
To divide that, so we should have something like, let's leave our answer to 3 decimal places. That's something like 2 point something.
2.3219.
19. So let's say 2, 2. So that's the value of x there. Then we'll come to this other one and take the log of both sides. Log 10. So log 10 so we use this. This becomes a product. The power multiplies the log. So what we have here, so y becomes log 4 to base 10 over log 10, 3 to base. So let's do that also. So log 4 to base 10. Log 4 to base 10.
That is, ew, it wrote error.
Did you do log 10 to base 4, log 4 to base 10?
0.6020.
0 what? Is it 209?
205.
So here will be 1. Okay. Log 3 to base 10.
That is 0.4771.
So divide both. So y becomes
and that is 1.2619.
You'll see. So that's the value of x and y. So that equation can see this is a bit long. But in our next class, when we treat logarithm, you get better idea. Any question? What is it by the
No,
time?
sir.
Let me see. 17 minutes. So time is fast spent. I was supposed to do one that involves quadratic equation. So I think I will include that as what you will practice on your own. So because of time, so I'm just going to do some brain work. So this is your assignment.
Sir, please, when you're done writing the assignments, I want you to scroll up so that I can screenshot the ones I missed.
Okay.
Like the ones I.
All right. I'll do that. So number one, if 5 to the power of 2x minus 4 minus 1 equals to 0, find x. So for x number 2, solve for x in 27 to the power of 2x is equals to 1 over 9 to the power of 3x minus 1. Number 3, solve the equation 8 plus 2x minus 1 is equals to 1 over 512. Number 4, if 5 to the power of 2x plus 1 plus 5 to the power of 2x is equals to 150. Find the value of x. And then number 5, solve the equation. Go to the power of x squared minus 24 is equals to 4 to the power of x. 6. I think we're just going to solve just 6 questions. So this is enough. Solve the equation. think these ones are enough to practice. Let me just make it 7. Okay, so these are all questions for practice. Somebody said I should make it 8. Should I make it 8? Somebody said I should make it 8. Okay. Since some, okay, then make it 8. So if 16 of 3x is equals to 1/4, 2 x minus 1. Find the value of x. I'm saying that I should add it to 10. No, this one is okay. Somebody said I should increase it to 10, but this is enough.
Sir, no. No, sir.
8 is enough. So this is all what we have. So I'll screenshot it and send this particular exercise to the group. So for those that say I should scroll, so this is the one that seems a bit compliant. You see this type in these exercises.
Sir, please, I want to see number 6. I have not finished copy number 6.
So any question? But this is where
So I'm done with that part.
Sir,
Yes.
concerning that one related to simultaneous equation, should we
Yes.
solve it side by side, or we can solve, if you finish solving for P, you can come back and, if you finish solving for X, you solve under for Y. Can we solve it
Yes,
like
yeah.
that? Or
Yeah,
we can solve side.
I just did it this one. You can do it, continue from under this together.
Okay, sir. Thank you.
So please, can you scroll down to number 8?
Number 8.
Wait,
You said number 8.
Yeah.
Number 6 or 8? Which one?
8.
That's in the exercise. The exercise will be sent to the platform immediately, so the video can get to us tomorrow.
Thank you, sir.
All right, thank you everyone for joining the class.
I
The more,
haven't even copied number 6.
pardon?
Or can I just screenshot? I've not finished copy number 6. Shh, mommy. Yeah, please, I want to screenshot it.
Okay, let me pause the record.